Hello. So this is part 2, chemistry. Paper 2, test 2, advance. First is more than one correct. Which of the following statements are correct? CCl3 minus and CCl2. CCl3 minus is like this, and CCl2 is carbene. Right? Which of the following is correct option? Correct option. Back bonding in both cases is from Cl to Cl minus. Cl to Cl minus. In this case, C minus is donor and Cl is acceptor due to vacant d orbital. And in case of carbene, C has vacant orbital, so it is sp2 hybridized. So it will be having a vacant orbital. This will be acceptor, and Cl has lone pair, so it is donor. It is donor. So in case of CCl2, the electron movement will be from Cl lone pair to carbon vacant orbital. While in the first case, it is C negative to vacant d orbital of chlorine. So first and second options are correct. Back bonding in CCl3 minus from C to Cl, while reverse in CCl2, that's correct. Direction of back bonding is just opposite in two cases, that's correct. C and D would be correct. Which of the following statement is correct for Be2H4? B2H4 would be like this. This would be sp2 hybridized. That means trigonal planar. Hydrogen does not have lone pair, so this bond will be banana bond. That is 3 center 2 electron bond. It will be a non-polar molecule. Non-polar molecule. B will be considered as more electronegative. Yes, all will get cancelled out. So it will be non-polar as well. Momentarily, octet is achieved for each beryllium atom. No, it will be, it can maximum have 6 electrons. 6 electrons. That means only sextet is complete. That too momentarily. Sextet is getting completed, not octet. Which of the following statement is incorrect for this FeH2O whole 5 NO sulfate? Incorrect. Here water is a neutral ligand, sulfate has -2 charge, and NO is +1. On that basis, iron will come out to be +1 oxidation state. 6 ligands are there. So coordination number would be 6. Charge on NO is +1. So it is a cationic ligand. Its brown color is due to DD transition. No, it is not due to DD transition. It is due to MLCT. That is metal to ligand charge transfer. Metal to ligand charge transfer. So A, B, C would be correct. Question number 18. Consider the following representation for bromido, chlorido, ethylene diamine, glycinato. Cobalt. Cobaltate 3. Yes, so this will be the complex. कह रहा है कि which of the following statement are correct? If both the halogen atoms are present at 1 and 3 position, bromine and chlorine, if both halogen atoms are present at 1 and 3 position, then compound should be optically active. But bidentate ligands can only be present at adjacent positions. Anyhow, there won't be any plane of symmetry. It should be optically active only. Compound would be less stable or highly unstable because bidentate ligand should be present at adjacent positions, but this it does not have plane of symmetry. So you can say it will be optically active. B. If both the halogen atoms are present at 5 and 3 position, then the molecule will be optically active. Molecule will always be optically active because it does not have plane of symmetry, neither center of symmetry. ये ए केस हो गया, बी सी। इफ पोजीशंस 2 2 6 and 5 are occupied by nitrogen atoms as donor sites, nitrogen atom as donor site, then it is a trans isomer. This is glycinate, this is En. This will be a trans isomer. On what basis it will be trans? The two nitrogen atoms, then it will be a face isomer. It should be फैक बनना चाहिए मैक्सिमम, ट्रांस तो नहीं होगा। 2 4 6 अगर रहते हैं फेस आइसोमर तो बन सकता है, इट वोंट बी अ ट्रांस आइसोमर। सी गलत हो जाएगा। डी, all geometrical possible isomers are optically active. Yes, all will be active because there cannot be plane of symmetry. This would be A, B and D. Question 19. Acidified K2Cr2O7, which is a very strong oxidizing agent, acidified, liberates I2 gas with Ki. Yes. From -1 it will become 0 and this will get reduced to Cr plus 3. This will get reduced, this will get oxidized. That's correct. Acidified K2Cr2O7 is used as a standard solution for the estimation of Fe2 plus. That's correct. Fe2 plus can also be oxidized to Fe3 plus with the help of K2Cr2O7. In acid medium equivalent mass, yes, because the N factor is 6. Acidified conditions में N factor is 6. So equivalent mass would be M by 6. D. On heating, ammonium dichromate. Yes, if we are heating, it must be endothermic process only. All of them are correct. Question 20. P ore is fused with Na2CO3 and air, gives yellow compound. Yes, it must be chromite ore, Fe2CrO3. FeOCrO3 or FeCrO4. It is chromite ore. Which one oxidation gives? Na2CrO4, which is a yellow colored compound. That's correct. This Q on acidified conditions get converted to dichromate Na2Cr2O7, red orange color. That's correct. And with lead acetate gives PbCrO4. That's a yellow colored compound. So P will be the chromite ore. Q would be Na2CrO4. R would be Na2Cr2O7. And S would be PbCrO4, yellow color. So A and C would be correct. Understood? Then we have section 2, paragraph type questions. Select the incorrect order of the basic strength. Basic strength depends upon the size of the molecule. Incorrect order they're asking. First order will be incorrect. Size ke directly proportional it is. Correct order should be this. But we are given with the reversed order. So this would be incorrect. B. Select the correct order for hydrated radii. Hydrated radii is directly proportional to size. Sorry. Is inversely proportional to size of neutral atom. Smaller atom will have more hydration, hence its hydrated radii would be more. So C option would be correct. Paragraph 2. Find the n value for which CH3 whole n SiCl whole 4 minus n on hydrolysis followed by polymerization gives a cross-linked silicone. For cross-linked silicone, we want this kind of compound. So that 3 times hydrolysis occurs, it becomes this. And on dehydration, on condensation, it gives polymerized in all the 3 directions. For this, n should be equals to 1. Which of the following is correct about silicones? Silicones are organosilicon compounds with having SiO-Si linkage. R3C, that's wrong. R SiCl3 on hydrolysis followed by subsequent polymerization gives linear. No, it will give cross-linked silicones when water is eliminated from the terminal OH groups of linear silicones. It gives क्रॉस लिंक नो इट, देन इट विल गिव लीनियर पॉलीमर्स। तो गलत दिया हुआ है, सी ऑन डी रिवर्स हो रहा है, और बी वाला भी गलत दिया हुआ है बिकॉज इट इज RSiCl3 नॉट R3SiCl। ए ऑप्शन वुड बी करेक्ट। सेक्शन 3 क्वेश्चन 25 मैच कॉलम 1 and 2। B3063 minus Al2CH3 whole 6 I2Cl6 C3N3Cl3। इसमें we have to tell the best possible. We should know the structures of this compound first. So B3O6 is this is B3O6 3 minus. It is a planar species. It has back bonding. It is non-polar. Upper limit can get cancelled out. It is non-planar, that's wrong. It is planar because it is sp2 hybridized. All atoms are sp3 hybridized. No, all atoms are sp2 hybridized. So PQR would be correct. Second is Al2CH3 whole 6. It will be a diboron type compound. Is it planar? No, it is non-planar. Does it have back bonding? बैक बॉन्डिंग तो नहीं होगी इसके अंदर, बैक बॉन्डिंग के लिए लोन पेयर ही नहीं है। नो बैक बॉन्डिंग। Is it non-polar? Yes, it will be non-polar. Is it non-planar? Yes, it is non-planar. Is it sp3 hybridized? Yes, it is sp3 hybridized. So it would be QRT. बैक बॉन्डिंग इसमें नहीं हो पाएगी because we do not have the donor. We do have acceptor but donor नहीं है। अच्छा, बैक बॉन्डिंग और ब्रिज बॉन्डिंग बोला। यस, ब्रिज बॉन्डिंग इज देयर। तो ये Q भी आ जाएगा, QRST। ब्रिज बॉन्डिंग इज पॉसिबल, इसलिए QRST हो जाएगा। I2Cl6, it will have similar shape, just hybridization would be different. It will be a square planar species. So is it planar? Yes. Planar. Back bonding, bridge bonding, obviously bridge bonding तो है ही। Non-polar, yes, will get cancelled out. Non-planar, no, it will be planar. Hybridization would be, इसकी हो जाएगी sp3d2, not sp3, it would be sp3d2, 4 सिग्मा बॉन्ड 2 लोन पेयर, तो इसका आ जाएगा pqr. Yes, then we have d c3n3cl3, so NCNCNC. So will this be planar? Yes, it will be planar. Will it have brick bonding, wedge bonding? No, nothing will be there. No bridge bonding now. No back bonding. Yes, back bonding also won't be there. Will it be non-polar? Yes, it will be non-polar. पूरा cancel out हो जाएगा. Is it non-planar? No, it is planar. It is sp3 hybridized. No, it will be sp2 hybridized. तो इसका आएगा p, r. Bridge bonding नहीं है, back bonding नहीं है. Yes, ठीक. 26. How many of the following are paramagnetic? Paramagnetic and 2.8 pm चाहिए मैग्नेटिक मोमेंट. 2.8 का मतलब 2 अनपेयर्ड इलेक्ट्रॉन्स. 2 अनपेयर्ड इलेक्ट्रॉन्स किसके पास है? O2 के पास है. B2 के पास है एज पर द मॉलिक्यूलर ऑर्बिटल थ्योरी. B2 के पास है इसलिए C22 प्लस के पास भी होंगे. O2 के पास है इसलिए N22 माइनस के पास भी होंगे. That's it. They will have 2 unpaired electrons. Now, which among the following compounds are white and water insoluble? White and water insoluble. So that would be barium carbonate, white PPT, and BaCl2, white PPT. उसके ऊपर अगर हम देखें तो NO2CrO4 is yellow, lead acetate will get soluble, KMnO4 is pink, calcium oxalate will be soluble, PbCrO4 is yellow, AgBr is pale yellow, Fe2O3 is brownish red. Then 28, sodium plus oxygen in excess gives sodium peroxide. That is O2 2 minus. Here bond order would be 1, and K plus O2 in excess gives KO2, which is O2 minus. Bond order would be 17 electrons. It would be 1.5. Superoxide. 14. This should be 1.5. bond order should be 1.5. So x plus 2y, x is 1 and y is 2 into 1.5, that will be 1 plus 3, that will be 4. तो ये आ जाएगा 4x plus 2y. That's it. This will be test 2, paper 2. Okay.